Hello and welcome to PB Edu. Please subscribe to our channel to find queries solution of yours. You can ask any of your chemistry doubts in the comment section below. So let's start with today's question. Here we have given an MCQ question in which we have to tell the incorrect statement. Choose the incorrect statement among the following. It is a P block element question. So here the first statement is given. HF is most volatile acid among HX. HX implies any other halo acid like HF, HCl, HBr, HI. These are the four halo acids that we study generally. Out of which it is given that HF is most volatile. Volatile means an liquid is going into its vapor form at any given temperature. So, if we talk about HF, here is hydrogen and fluorine, the most electronegative element. So, here in case of HF, we find hydrogen bonding. Like if I show it by red, fluorine is electronegative element and with hydrogen it forms hydrogen bonding. Intermolecular hydrogen bonding. It makes the HF molecule in a big form. It is in association with each other, which makes it difficult to go from liquid to gaseous state. It means HF is the least volatile. It is the least volatile. It means the incorrect statement is given in option first. Therefore, option first is correct for the given question. It is the incorrect statement. Next is Na2O2 is having ionic and covalent type of bonds. Na2O2, if we talk about its name, it is sodium peroxide. Sodium peroxide. And we will see its structure. So it is oxygen-oxygen bond, the peroxide bond, and with it the sodium. Sodium donates one of its electron because sodium has one electron in its valence shell. So sodium donates it one of its electron and forms ionic bond. It gives one electron to this oxygen and this sodium gives one electron to this oxygen and gets a positive charge. So like this, we can see that there is a covalent bond among oxygen atoms. This is a covalent bond, and here among sodium and oxygen, we can see the ionic bond. Ionic bond. So now we know that in case of sodium peroxide or Na2O2, there are both type of bonds, ionic and covalent. Therefore, this statement is correct. But for the given question, this is not the answer because this is a correct statement. Next is sodium acetate. CH3COONA is sodium acetate. Is having identical CO bond lengths, while it is not true in case of CH3COOH, that is acetic acid. So here it is given that in case of sodium acetate, the CO bond length is identical, while not in case for acetic acid. We will see the structures. So in case of CH3COONA, we know that in case of oxygen and sodium, there is an ionic bond. So here we can write the electrons like this. And we will also write the structure of acetic acid. CH3COOH. In case of oxygen and sodium, the electrons are free to get in resonance. So the oxygen lone pair goes like this and the pi bond shifts like this. Pi bond electron shifts like this. So we can see the resonance structure like this. CH3C, here single bond O and minus charge. So sodium will go to it. And here the oxygen will form double bond with carbon. And in case of acetic acid, the oxygen and hydrogen bond is covalent bond. So the lone pair of electrons are not able to shift to form to make a resonance structure. Therefore, resonance is not possible in case of this covalent bond, a covalent compound. So we can see that in case of sodium acetate, If we see the first bond, there is C double bond O, double bond character, and in this case, there is a single bond. And if we see the second bond, there is a single bond, and here C double bond O. So what we have seen that in both the case, in both the structure, both the carbon oxygen bonds are equivalent because both have carbon oxygen double and single bond character. So here the electron density is like double bond middle between double bond and single bond. CO double and single bond. And both the oxygen has negative charge. There is only one negative charge that is between shared between both the oxygen atoms. So the C double bond O or the CO bond length are equivalent. And it is not in case of acetic acid. Here, if we see the bond length of C double bond O, it is 1.23 angstrom, and bond length of C single bond O, it is 1.32 angstrom. But in case of sodium acetate, the bond length of CO bond is 1.26 angstrom. That is in between the CO single bond and CO double bond. Therefore, the bonds are equivalent in case of sodium acetate, and therefore this statement is correct and not for the given question, but it is correct statement. Now next is PP overlap is more strong as compared to NN overlap in axial type of bond formation. So we can see that if we are talking about PP and NN, phosphorus is a bigger atom. It has 4 shells while nitrogen has 3 shells. So it is a bigger atom. And if we know that it is a bigger atom, therefore the bond formed between phosphorus would be longer. And if we see the general electronic configuration for group 15 elements, both are group 15 element, it is NH2, NP3. So it means it always have a lone pair of electrons. Lone pair of electrons. So we can make lone pair here. And also in case of nitrogen, now, in case of axial bond, the bond is formed at internuclear axis. If here the sigma bond is formed like this, because nitrogen is a shorter, smaller atom, therefore the repulsion between the lone pairs is more. Repulsion is more, and it is less or no repulsion in case of phosphorus because the bond length is longer. Bond length is longer. So no repulsion between the lone pairs, therefore it is stable, while not in case of NN axial bond. So here PP overlap is more stronger, it is correct, than nitrogen-nitrogen overlap. Therefore this statement is correct. The incorrect statement was given in option first, therefore option first is correct. Thank you, and please subscribe to PB Aero channel for more solutions of your queries. Thank you.